All right, here's a good example of an exponential function and using this formula here to help you solve different things. The first question asks you to find the exponential growth function. And for that, what you do is you plug numbers into this equation, but you don't plug in anything for t. Okay, so I'm going to write p of t is equal to p0 stands for how much you start with. And it looks like there's, pardon me, starting with 6.18 million. So that's that. And then I have e to the k is the interest rate, if you want to think of it that way, or the doubling, how much stuff is going up by. And this one is going up by 2.14%. So I'll change that to a decimal. And then that's all the things I have to plug in. So that's the end of letter A. So the exponential growth function would be that. Then they say, what's the estimate the population in 2018? Well, I started in 2012, and if t is the time in years since something happened, then t to go from 2012 to 2018 would be 6 years. So I'm going to put in a value of 6 for t. So in B, I'll use the same formula. P of t is equal to 6.18 e to the, I guess I didn't need to write this over again, but I'm going to put a 6 in for t. So the population after 6 years is equal to, and again, this is just a descriptor. It's not anything that you would multiply. So it's just the population after 6 years. That's all that is equal to 6.18 e to the 0.0214 times 6. Now I think that you can put that all in your calculator. Let me see if I can do that. So 6.18 and then e. Oh, I don't know if this calculator has an e in it. Okay, I found a calculator that worked. So the population after 6 is equal to 7.03, we'll call it, million. So after 6 years, the population, if it continues with that same growth rate, then the population will be 7.03 million. Okay, then they ask, when will the population of this metropolitan area be 8 million? That's a good question. So I need to use the same formula. So P of t, and that's population after a given time, is equal to how much it starts with, e to the k, that's the growth constant, times time. But this time they're saying the population after a given time is 8 million. So that's what goes in for this number right there. And notice it's not P of t or P of 8, it's just 8. Population after a given time is 8. Is equal to how much it starts with, 6.18 million, e to the k, 0.0214, times t, which we don't know. And that's what we need to solve for. So to solve for that, I'll need to divide both sides by 6.18. So divide by 6.818. Okay, maybe I'll do that on my calculator. 8 divides 6.18. 8 divide 6.18. Okay, 1.29, call it. Maybe I'll put some other numbers after that. Is equal to e to the 0.0214t. And now here I have to solve for something that's in an exponent, so I need to use logarithms. So I'll change this to log form. So it'll be 0.0214t is equal to log base e of 1.2944. Now just to rewrite that a little bit, 0.214t is equal to log base e is the same thing as ln, 1.2944. Okay, and then I'll divide both sides by 0.0214. So ln 1.2944 divided by 0.0214. Okay, Okay, and so if you do that, I just pause to do it on my calculator. So if you do that, you come out to t is equal to 12.06, and that's time, so that would be years. So it would take 12 years for the population to get up to 8 million. Now the final question is another interesting one. It says find the doubling time. So the doubling time is sort of an interesting one. I'll maybe do it right beside here. Let's go green. So in D, they want the doubling time. So again, I'll use this formula, but the amount I'm starting with is 6.18. And if you want to know the doubling time, you want to figure out when will that be double. And so the amount that it's going to be double will be, you just times that by 2. So it's going to be 12.36 is equal to e to the k, I know is 0.0214 times the time. And so I'm going to solve for time. And I'll solve that exactly the same way I did this one. So 12.36 divided by 6.18 is equal to e to the 0.0214t. And you divide those, that'll be 2 is equal to e to the 0.0214 times t. Change it to log form. So it'll be 0.0214t is equal to log base e of 2. And log base e of 2 is, log base e is the same as ln. So ln of 2 divided by 0.0214 is equal to t. Do that on your calculator. So I put it in already. It comes out to about 33 years is how long it would take to double that population. Okay, hopefully that helps with that question. Many of the questions that follow this are very similar to this one. Okay, hope that helps.